Think of data dispersion in the cloud as a man in the cloud. And this man spreads or disperses the data across multiple locations. To do this, data is broken into fragments and spread across those multiple locations to enhance availability, redundancy, and security. This concept is similar to a RAID, redundant array of independent disks, but on a more global distributed level, where the disks reside in multiple locations, e.g. regions across the world. And there are different data dispersion techniques used by cloud providers, but generally these are erasure coding and bit splitting. Now, to understand the difference between these two data dispersal algorithms, let's visualize some examples. Let's say we have the original data, which is 64 bits in this example. And let's say we're going to apply the technique of erasure coding on this original data, the 64 bits. Technical keynote: the actual erasure coding algorithms will typically establish some variable number of chunks into which data can be divided that will result in a different minimum number of chunks required to recover the data. But for the purposes of this example, let's say the data was broken into 6 16-bit blocks. Now these blocks or chunks can be stored at any location. And in this specific example, if any 4 of the blocks or chunks can be accessed, the original data can be recovered because 16 times 4 equals 64, the original data. And if you are wondering what the other 2 blocks or chunks are for, they are for redundancy or parity, similar to how this works in a RAID array. Meaning there must be a minimum number of blocks or chunks to be available to recover the data, and these must be spread across the multiple locations. It's also worth noting that when data is dispersed internationally or between different legal jurisdictions, many different data management control issues may occur, so please be sure to check with your legal teams. Moving on to our next technique, which is bit splitting. Again, this involves splitting up the data and then dispersing it across multiple locations. However, there is a difference. In bit splitting, before the data is split, the data is encrypted, and then this encrypted data is dispersed into the multiple locations. Then there is an added benefit of an additional layer of encryption added to each of these chunks individually by each of those separate locations. This means that distributed data requires multiple keys held by different entities to decrypt the data. So in other words, bit splitting adds the encryption, but it complements the erasure coding technique, and actually in reality they work together like this. So to summarize, the ultimate goal of data dispersion is that data is broken into fragments and spread across multiple locations using erasure coding. And erasure coding can be used in conjunction with or without bit splitting, which adds a level of encryption to that dispersion. Or put simply, bit splitting is like adding encryption to a RAID array. And erasure coding is like using parity bits for that RAID array, which in this case would be striping RAID 0 at a global distributed level. If you found this video informative, it would be super helpful if you could like and subscribe to help support this channel's growth. Every single like really does push this video further and further up YouTube, which in turn helps this channel to grow immensely. Thank you for watching today's video. I hope you enjoyed the content as much as I enjoyed creating it. If you would like to see more content like this, it would be super fantastic if you could leave a like and subscribe to help support this channel's growth.